Hello, my name is John Gilman, and this is my presentation for the genetics data analysis class on QTL analysis of mice for an F2 intercross. I'm just going to start off with some background information. Quantitative trait loci analysis, or QTL, involves linking phenotypic data and genetic data, which are generally genetic markers, in order to explain the genetic basis for variation in different traits. This statistical analysis can be used to look at a large number of markers and how they are associated with a number of phenotypic traits, such as weight, height, or certain blood chemistry values of interest. So continuing here, an F2 intercross, which was done in this study, is a mating setup between brothers and sisters from the F1 generation. An outcross between two inbred strains, or between one inbred strain and a non-inbred animal that contains genetic variant of interest, is almost always the first breeding step performed in a linkage analysis, which is true in this case. So continuing, QTL uses an algorithm and statistical software, R in the case of my analysis, to compute LOD scores, to determine the linkage between particular genetic markers and a phenotypic outcome. Using multiple permutations of the data, an LOD threshold can be calculated that creates a boundary at a significance level of interest that can help determine how significant the markers are related to the phenotype. Here's a brief description of the data that I will be working with. Again, it was an intercross with 266 F2 female mice created by brother and sister mating of the F1 generation. The B6 and BALP phenotypes were used, and the blood was taken before the study began and after the end of the 12-week of high-fat feeding period, and the diet that the mice were given contained 21% fat and 34% sucrose, as they were interested in looking at markers related to type 2 diabetes, so they gave them what they called a Western diet, just high in fat and sugar. So continuing, the original QTL was performed using JQTL and Map Manager QTX software. 1,000 permutations of trait values were run to define the logarithm of odds score threshold required to be significant or suggestive for each trait. So in the study, significance was defined as a p-value of 0.05 or above, and a trait that is suggestive, or a QTL that is suggestive, is defined as a p-value from 0.05 to 0.63. So not quite as strongly significant as a significant QTL. So here's a figure included in the paper. QTL analysis was done with this population on the phenotype of interest, which was body weight. So the results from their analysis, they had one significant QTL and two suggestive QTLs. So you can see here on chromosome 1, you have a QTL that is above the 0.05 threshold, and on chromosome 9 and chromosome 19, you also have QTLs that are above the suggestive threshold, but they are below the significant threshold. So what was I interested in doing? I'm interested in looking at adding a covariate, which is the skin color of the mice, and seeing how that affects the results for body weight that were displayed in this paper. There were 5 different skin colors in the data set of 266 mice that I've converted for analysis. So 1 equals white, 2 agate, 3 black, 4 light brown, and 5 dark brown. And here's just a breakdown of the number of mice in each category. There was 61 for white, 82 for agate, 32 for black, 36 for light brown, 9 for dark brown, and 46 that did not actually have skin color data that were omitted in the analysis. So here's just a histogram of the distribution of body weight. Again, it looks roughly normal, so there are no problems with the distribution of the phenotype of interest here. Next, I just have a genetic map of the markers generated in R. Again, this just shows the markers that were included in the analysis across all 19 autosomes for the mice. So here's another output from R that I generated. This is the highest LOD scores for each autosome without covariates. So as you can see, chromosome 1 had the highest LOD score of 3.3. That kind of makes sense based on previous figure. And the low end was pretty low, about 0.15. So this is the plot of real interest that I generated. So this has your two significance thresholds, the significance of 0.05 and then the suggestive trait of 0.63. So this is the LOD scores without any covariates included. So you can see on chromosome 1, there is a suggestive trait above the red line. And then there's one here on chromosome 6 that is fairly close, but not quite suggestive. And here is similar data that I presented a couple slides back with the covariate of skin color added. So I'm not sure if you can tell, but the LOD scores in general are lower. You have a highest LOD score on chromosome 1 again, and that's only 2.36 in this case, as opposed to 3.3 from the last output. And here is the plot with both significance levels, 0.05 and 0.63, with skin color added as a covariate. So right off the bat, you'll notice that there are no QTLs that are suggestive or significant, as none of them reach this red line as a threshold. And there are a few, mainly chromosome 1 and 6 again, that are close to the line but do not reach it. So here's a discussion of the results. There is one suggestive QTL for body weight when no covariates were added. And there were no suggestive QTLs for body weight when skin color as a covariate was added. The LOD scores were lower in general for the analysis, including the covariate. This could suggest that skin color potentially had an effect on the significance of the QTLs. It might be related in some way. More of a discussion. I think there are two main reasons for the differences in the observed significance of LOD scores. Reason one, there's a smaller N in the covariate analysis, as 46 of the 266 mice were omitted based on not having skin color data available, so that could significantly affect the results. And then reason two, which is what I was more interested in, is QTL analysis adjusted for skin color actually had effect on the overall significance of the markers analyzed. So in conclusion, the LODs are generally higher and closer to either threshold in the analysis where no covariates were included. The plots and analysis provide evidence of this, and it might have been the case considering the differences noted in the two analyses. I do not think it's outside the realm of possibilities that skin color had an effect on the significance of these QTLs, but for the reasons I listed above, mainly that 46 of the mice were omitted, I do think in order to be certain of this, a more detailed analysis would have to be performed. And here's a reference to the paper where I got the data from. Thank you very much.